Right. So, hope everyone can see the screens. I'll be talking about today to you about scaling your build logic. And before we start, I just want to get a quick show of hands. Who knows this little elephant? Come on, don't be shy. I'm sure everybody knows this elephant. It's a very famous elephant that most of us know, even if you're not working with Android as much. It's a build tool that is not the only build tool we can use on Android. It's one of the officially recommended ones and supported ones by the Android team. But as a disclaimer, in this talk, I'm gonna focus on Gradle. So if your Android project doesn't involve Gradle, some of the tips and techniques I'm gonna show here today may not apply as easily as maybe I'm showing it. But that's one of the disclaimers I want to talk about. The other one, I wanted to get out of the window. What do I mean by build logic? So I'm gonna examine a bit the definition of it. So what I've done is what everybody probably does in 2025 is ask an LLM and asked a couple of times because I wasn't happy with the first answer, and it spit out something like that on the screen. I'm not gonna read it, and I think maybe the only thing that's worth highlighting is the declarative instructions part. I would also argue that probably depends on how you code your build logic as well. But it also says it transforms source code. I mean, it's not wrong, but when I read it, I still didn't understand what they mean by build logic. So, and maybe also worth noting that, yes, as I said, build logic by definition, I don't think is declarative. We just aim to write it in a declarative way. I think even Gradle has acknowledged that by their latest work on the declarative Gradle. That's currently something they are developing. And actually, when I read up on that, I went to the blog post about declarative Gradle. They actually had a pretty good definition for build logic. It's basically how the software will be built, and it adds new capabilities, integrates different tools, supplies conventions, and I think that's pretty much spot on. So I give a point to Gradle on that, and not to our AI overlords. So some of the goals I want all of you to, by the end of the way, walk away with some better understanding of some Gradle fundamentals. This is not a Gradle one-on-one or a Gradle workshop, but I do want you to maybe have a better understanding of some of the fundamentals, how to create a Gradle plugin briefly, what are precompiled scripts and what are convention plugins, build source, included build, what are the differences, and in the end, what I found the least information about on the internet is how to write your own custom DSL and how can that help you scale your build logic. So let's get started. This is a baseline project. Probably everybody's familiar with a settings script file. That's basically your entry point to your Gradle build. And it defines your projects that include line at the end. If you have, and I guess a caveat again, Gradle likes to call everything a project. We might colloquially know them as modules, but Gradle project is a collection of projects, and you can even combine different projects. So for the sake of sanity of our own, I'm just gonna call them modules from there on, but I'm referring to projects within the project. And if you have this in your app, you're either a hobbyist or you're working maybe on greenfield projects all the time. Lucky you. I guess the disclaimer that I'm going to give is that maybe some of the techniques I'm going to talk about here may not apply if this is how your project looks like. But I'm sure most of us work at relatively companies that have relatively larger projects that's just a single project, single module project. There you go. I already slipped on the words. But nothing is a silver bullet. So do consider the stage your project is at. I'm going to try and go through different phases, and maybe you'll find something for you from this talk. So let's create a more realistic project finally. And I was really excited that I could finally highlight this little tool that I've been using for a long time to benchmark things. It was created by Inaki Villar at Gradle. It's on his personal GitHub, but it is a nifty little command line tool that helps you generate projects that are larger in scale. So all you have to care here is that I'm generating a project for us to work with that has 100 modules in it. This hopefully is more realistic to what most of us dealing with on a day-to-day basis. And by the way, I'm going to publish the slides afterwards. You're gonna find it, and there's footnotes at the bottom that that you can read more about some of these tools that I'm highlighting here. So now our script file looks more like this, and hopefully more of us can resonate with what we see now on the screen. It has a lot more include lines. Actually, we have hundreds of modules here. We just generated it, and each of them have build scripts with them, and each of the build scripts have plugins applied, like our Android Gradle plugin, Kotlin Gradle plugin, or KPT, or some other things. There are some what I would maybe call actual build logic, that this is something custom. We are generating here the namespace based on the project name, just normalizing it. And then there's Android extension configuration. Hopefully all of you are familiar with this, so I'm going to just skip through it. But now this hopefully highlights some of the growing pains. If you have hundreds of modules and each of them contain those build script files, and we haven't done anything about it yet because we've just been growing fast. Some of the growing pains could be that we see a lot of duplication across all those files. And misconfiguration can go unnoticed very easily. Somebody changes the JVM target language in one of the modules, and that doesn't apply everywhere. Then all of a sudden we have producing different artifacts that have different target language, and that will usually fail, and that we will see. But sometimes there are other issues that you can misconfigure that won't be showing. There's also a lot of larger surface area to own. So maybe your team is not big enough yet to have its own dedicated platform team to own these. So it's most likely all of your colleagues and coworkers who co-own all of those build scripts and build logic. Therefore, it's much harder to maintain. But it also becomes tedious. And this is what I want to highlight, that anytime you want to migrate from plugins or tools, or there's breaking changes in one of them, changing that in all 100 files becomes a really big challenge. Just as an example that I'm going to come back at the end, like what if you want to change from, let's say we use Dagger Hilt with KAPT, but we want to go and get rid of KAPT. And maybe Dagger is the last dependency that uses it, but you want to get away from it and use KSP. Now you have to basically update all the plugins, all the build script files, change, maybe you have to add a new plugin like KSP. Then you have to also remember to change the dependency configuration from KAPT to KSP. Maybe you need to do some other things, but you do this 100 times, and by the time you manage to commit this and open a PR and get somebody to review it, just pray that there's not 10 other projects, 10 other modules popping up in the meanwhile from other people, because the world doesn't stop when we change things. So it does slow down migrations when you end up at this scale. So how do we address this? Let's start it. And this is where you can start thinking that maybe you just have 20 of them. You don't have 100. Maybe you're not at that level yet. But let's get started. Let's try and just find some parts that are common. And again, do what I did before, search on the internet. Look through Stack Overflow, Reddit, subreddits, ask the LLM again. Unfortunately, I've seen this many times pop up just using sub-projects or old projects. But I mean, hopefully many of you can quickly point out that this will actually not even compile. And obviously, because we don't know which accessor to use, like we are applying now to all sub-projects, which is what we want. We want to abstract the code out to one place, write it once, apply it everywhere. That's the spirit. But the sub-projects doesn't know when we write this and apply this, what type of Android extension to get here. So can be a library, can be an application, whatnot. So, I mean, we can also fix this, yes. We can start writing a bit more smarter build logic here, depending which plugin is applied, uh, application or library, and then we use the base extension between them that's commonly shared in the Android Gradle plugin. But this still doesn't feel right. So the first tip that I want to give you is to try and avoid using all projects and sub-projects where you can. It sort of breaks the boundary between the projects, because wherever you write them, they can sort of inject changes to the others, and that's actually working against to some of the project isolation work that they are working towards to in the latest Gradle versions, which will give us a lot of benefit in speed and performance. I mean, that said, using all project and sub-project will have a performance hit on you because it has to iterate over, as it says in the API, all the projects and all the sub-projects. And it becomes harder to debug if you imagine you have this somewhere, because it can be literally anywhere. You don't know where it's originating from, the change. You have to really understand every bit of the code, but when you're at tens of thousands of lines of even build logic potentially, it becomes very hard. So instead, what's recommended, and again, maybe not always instead, there are still use cases of all projects, and it's not being deprecated because of the new work that they're doing. But if you don't know why you should use it, just try and avoid it. So instead, let's talk about precompiled scripts and convention plugins. So what are they? Precompiled scripts refers to a reusable build script file. We just saw a lot of build script files. So they are these .gradle files. They can be written in both Groovy or Kotlin with Kotlin DSL. But in the end, it's a build script file that encapsulates the shared build logic. So it's what we want. What about convention plugins? Well, so that refers to a Gradle binary plugin that encapsulates shared build logic. It sounds pretty much the same. Wait a minute. Well, is it the same? Pam definitely thinks so. They sort of are. I think we can both agree that they are written similarly in the same languages, same styles. They both encapsulate the same things. They are actually plugins after all, even though I said precompiled scripts are scripts, not plugins. Behind the back, Gradle generates plugins for them. So you just write scripts, but in the end, they're also plugins. So the only difference is actually how you implement them. And let's take a look at that. If you start at precompiled scripts, we just basically add a new project in our project. Again, slip of words, module in the project called build source, drop in a build script file, add in the plugins we need. And the only thing we need to add here is the Kotlin DSL precompiled scripts plugin. And now let's take a look at our previous build script, one of the many hundreds. It looks like this. How does the precompiled script look like? Pretty much the same. We can copy paste most of it besides the dependencies. And I mean, you can actually put some dependencies there that are common, but you most likely don't want to put your like project dependencies there and let the use case to define that. But otherwise, everything can be the same. What really matters is actually the name of it. As you can see, what's before the .gradle is basically how we call the file where we put this in the build source. And that's actually going to be important because the generated code going to use that as the plugin ID. And this is the generated code that it generates at compile time. It basically, as you can see, creates a Gradle plugin. And here, now we're applying it to one of the modules. All you have to do is remove all the build logic from that module and just add that ID. And that's actually the ID as we saw it, as we showed before, the name of the file. Now you sync and it's actually done. Now you have to do that for the other 100 build logic files, build script files. With a bit of Command F, Command R, find and replace, you can get rid of all of that. But there's still some build logic lying around. There's the root project. We can take that as well. What the root project usually defines in most cases is the top level plugins you apply that you want to be applied across the whole project. What this does usually is just pins the version. As you can see, it doesn't apply anything. It says apply false at the end, but it's used to pin the version. We create a root precompiled script, but we don't add anything there. It's because in precompiled scripts and in convention plugins as well, you don't, in the root project plugin, you don't define the version. You do that by adding it as a dependency to your build source project, because this generates a jar that's then gets injected to your root project and therefore knows which version to pull for those plugins that you apply through the precompiled scripts. And now you apply that back to the root project, and that's it. All good, right? Well, another tip I want to give all of you is to try and avoid build source. It can be useful for projects that don't care about speed, or you have a small enough team again that you don't necessarily wanna care about that problem. But it is a special directory. As you can see, we didn't have to define anything. It doesn't have to be included in the project. It's a special project that gets automatically picked up by Gradle, but it is tied to the root project. That means if you change anything in there, it invalidates the root project because it's added to the root class path. And that therefore any change makes the project out of date and your remote cache gets invalidated. You get to a point where that affects your speed, then you should probably try and stop using it. Instead, you can use composite builds, also known as included builds. And I want to give a shout out to my friend Joseph Raska, who gave really good Medium article about it a couple of years ago. I think the contents of the article still applies pretty well. So how do you move away from build source if you want to? You basically just rename the folder and now add that one line into your settings script, which is the name of the project, the folder name basically. And once you do that, actually you just sync and you're done. Now you compose two root projects into one project, and therefore they are separated. You can work on them much better. But let's not stop there. We want to move now to convention plugins, mostly because that gives you access to some of the APIs through the artifacts that might be much better to be written in a more imperative way. So what we just basically have to do is remove that plugin that we added, the precompiled scripts plugin, and add a new block called Gradle plugins. This helps us to just publish these plugins. We create the three plugins, basically, the one for the root, one for the Android library, and one for the Android application. And actually, there we define the classes for these plugins, and we are now going to take a look at two of them. The root one, because it's fairly simple, and then the library one. The third one is pretty much the same. So the plugin looks like this. We might have seen the generated one before. It looks pretty much the same. We implement the plugin interface. We then define the type of it as project, and we override the apply function. Whenever people apply our plugin, it will run the apply block. I'm not adding any logic here again, besides a small require check. Just want to make sure people don't misuse my plugin. It should only be applied to the root project. Same with the library one. It's might not be as visible because the screen is quite small and it's long list of code, but basically you create the same plugin as before. You start writing your code from the build script to this more imperative way of writing it line by line. You add the plugins, and then you get to this point where you just can't say Androids and curly braces. You can't have that accessor at this point. You need to understand to get the extension from the project by the type. And this is one of the challenging part of writing like this shared build logic in convention plugins, is that this moves you to understand their API much better. And this is when I recommend that if you ever deal with Android Gradle plugin, go to their developer.android.com website and look it up, because that's the easiest way to figure out what the extension is called. But once you get that extension class correctly, and then in the apply block, you get access to the same API as before. You can configure everything. So it's pretty much the same. And applying it, you don't have to change anything, because in the plugin definition, we gave it the same name. So now we moved from precompiled scripts to our own convention plugins. These are our own binary plugins that we write. And we applied it already everywhere. Nothing has to be changed in the use case sites. And we migrated from one approach to another. So we're done. We went from thousands of lines to hundreds of lines of code. Great. We spread the build logic from hundreds of projects in this case to one, the build logic project. And now we also owners of Gradle plugins. Saying locally because publishing them is a whole nother talk. But there's still more. There's still build logic laying around that we haven't taken our eyes on. Well, we actually did see this. This is the settings script file. It includes all the project module inclusions, but there's more usually in these settings scripts. This is actually the root entry point to our project. It usually also takes care of things like build features from Gradle, dependency management, filters, in case you want to avoid not to pull down the dependencies from different repositories. You can do more, but maybe even build cache-related configuration. So there's build logic here as well. You don't want that to be contained in your settings scripts file, especially if you start composing multiple projects together. So what you can do actually is you can we just need to create another convention plugin, basically. I would usually advise you to actually create it into its own project, because as we apply this in our settings script very early on, you don't want the whole build logic project we just created before with all these dependencies and all the convention plugins we created to be initialized maybe. So usually you create a special custom settings project where you create your own settings convention plugin not to overload the class path there. But it's the same way as we did for the other ones, and same way to create the plugin. The only difference is instead of the plugin being type project, the plugin is of type settings. And now we created our own settings convention plugin. Applying it is pretty much the same as well. The only difference is that you need to add the included build, the composite build declaration in the plugin management block. So when you call the plugins block with your sample settings convention plugin, it knows that it can get it from the plugin management class path, the dependency we just created. Pretty much done. Now I want to give you a cool little tip that probably not many people know about, is that Android Gradle plugin has its own settings plugin as well. And it ships things like setting the compile SDK, min SDK, a few other of these properties in one place in your settings Gradle file, instead of every single library or application build script. It also has things like you can set custom profiles for R8. And I think that's one of the main reasons that they found that this is actually very useful probably to publish, that it helps you to provide custom profiles to R8. I'm not going to go too much into that because that's a whole other talk of how to tame R8 itself. But they released this plugin March 2023 with Android 8.0.0. There's not much documentation around it, so I just added this slide to show how to basically add it in if you want. In your settings script, you just define com Android settings and the version of your Android Gradle plugin. But doing this feels bad now because we just talked about how do we remove all this logic being declared all over the place. We want it to be in our own custom convention plugins. What do we do now? Well, it's actually as simple as adding the dependency uh, into our build logic settings project and into our sample settings plugin. Now we just basically apply it similarly. And through the extension, you can see we can configure min-SDK and compile SDK. And now we can go into our convention plugins and remove those lines where we set this already because we just set it in one place. So now to recap, we have understood how to structure our build logic across our Android projects, hopefully for the better, depending on the scale and needs you have. Creating and applying convention plugins, but you may already have the questions ready to like, well, this is not really the reality because I use Compose and that requires me to add the Compose plugins and enable the build feature for Compose in the Android extension block and add a bunch load of dependencies for all the Compose artifacts that I want to use. And I have 50 presentation projects, modules where I use Compose. So now I have to do this everywhere. Or the same goes with Dagger Hilt. If you use Dagger, I have to add the KAPT plugin everywhere, and I have to add the Hilt plugin everywhere, and same. Like this also adds up as being build logic. So what if we could provide to our teams and fellow engineers a DSL like this, where we could say sample company like, let's say Wise, and then they could just say, I don't care about how do we set up commonly compose across our project or how do we configure Dagger. I just want to enable Dagger on my project, and I want to use Compose UI on my project. And this also hides away the complexity of when we want to migrate away from it, then we just change it in one place instead of having to update in all those places. How do you implement something like this? This is also something that I haven't found much information online yet, but it's pretty simple, to be honest. You basically create a base plugin, and oh yeah, we're creating yet another plugin. Well, you do this because you don't want this to be tied and replicated again in all your convention plugins around the Android application, the Android library types, or the JVM projects you have. You want this to be added everywhere. You want to have access to this DSL that you're creating everywhere. And you also need to create a DSL marker. We create a marker, an annotation, which when we're going to write this DSL, we highlight all the accessors with it. This helps us to limit the scope. So when people will start writing sample company curly braces, it will help both with the discovery, but also will help with the autocomplete of not giving you the access to the ones that are not part of that scope. Then you create a core DSL class. We create a nested one for the feature, and then create the features itself. We're going to quickly take a look at it. The sample plugin is just a plugin as before. Only difference here is that we are creating an extension, that line, where we define how our extension should be entered into. In this case, sample. Then we create the marker, as I mentioned, the annotation. And after all, to the extensions later on, you all have to make sure that annotation is there. And then we basically create the entry point to the features down below. Now to the feature part of that API, you create a class again, you annotate it, and you start defining your features down below. And all you have to know is that this is an action. Therefore, when people call into it, it will enable that feature, as you can see, and that is defined on our feature itself. Each feature has an enable function. So when they call into sample features compose, this gets trickled down and enables that feature. And when the apply to, when after the evaluation of the project, after the configuration of the project, it runs the apply to blocks. And at that time, when the feature is enabled, it will apply the plugins. Cool. So this way we are providing a declarative, hopefully discoverable API to our team members, and we hide the complexity away, and it will allow for easy migrations. And here's an example. When we moved from using KPT, we wanted to avoid having to update it in all places. We hide it away as a flag on that DS and on that API, and say if we turn on KSP, it automatically adds the necessary plugins and necessary dependencies to the project. And for discoverability, given that we annotated things and we added proper documentation, then it will make it self-explainable to your engineers, because they hopefully still want to understand what's happening behind the back. They just don't want to care how it's configured, how the build logic is written. Cool. And given that I'm running out of time, I want to give a few acknowledgements. So this article is 4 years old by Square, written by Tony Robalik, and it sort of expands on similar problems and how they tackle it. Obviously, Square is at a whole different scale with 3,500 modules and probably more ever since. But he encapsulated in this article pretty well what I was trying to give away in this short 30-minute, 35-minute presentation. There's another repository that I want to highlight, is the Now in Android. It's serving as a good inspiration for the Android community, and if you haven't seen it yet, I do recommend you to go and take a look at the PRs. They are pretty good at documenting the changes they're making. It's really run by the dev advocates at Google, but also by the community. Many of you maybe even contributed to it. They even have a PR for the changes when they moved from precompiled script to convention plugins. So I'll link that down below as well. And the other one is the team behind Slack mobile platform team. They went a step ahead and they open sourced their build logic completely, all the convention plugins and all the other build logic that I actually also sort of walk you through, like creating a custom DSL to turning features on and off. I heavily inspired from their work there. So you can find me on Mastodon if you have any questions afterwards. But also I'm gonna post the slides there with the links. But if you have any questions now, I'm open to taking some questions.
Thank you. So I'm not a Gradle expert, by the way. In terms of stability of all the Gradle internals that this approach depends on, like how much do you need to change between versions of Gradle?
So we've been using this approach for a year and a half, maybe. I don't necessarily think we had to change too much. There was obviously a lot of change around Gradle 8, and maybe there will be some around Gradle 9, but I think many of those changes actually will impact you, even if you don't use this approach. So I wouldn't say many. You definitely need to be on top of your of your deprecation warnings, but otherwise it's to be honest, it's actually maybe better, because at this point you have all your logic in one place instead of scattered across all over. So updating it is really just change it once and apply everywhere. Cool. I mean, if you have any questions afterwards, come grab me. And otherwise, thank you all.